Python dates. Python's datetime module provides classes for manipulating dates and times. Here are some key features. 1. Date class. Date, year, month, day, creates a date object. Today, returns the current date. Year, month, day, attributes of a date object. 2. Time class. Time, hour, minute, second, microsecond, creates a time object. Hour, minute, second, microsecond, attributes of a time object. 3. Datetime class. Datetime, year, month, day, hour, minute, second, microsecond, creates a datetime object. Now, returns the current datetime. Year, month, day, hour, minute, second, microsecond, attributes of a datetime object. 4. Time delta class. Time delta, days, seconds, microseconds, creates a time delta object. Days, seconds, microseconds, attributes of a time delta object. 5. Formatting and parsing. Strftime, format, formats a date, time, or datetime object as a string. Strptime, string, format, parses a string into a date, time, or datetime object. Example usage. From datetime import date, time, datetime, time delta. Hashtag date. D equals date, 2024, 3/16. Print, D, hashtag output, March 16, 2024. Print, date.today, hashtag output, current date. Hashtag time. T equals time, 14:30, 0. Print, T, hashtag output, 14 hours and 30 minutes. Hashtag datetime. DT equals datetime, 2024, 3/16, 14:30, 0. Print, DT, hashtag output, March 16, 2024, 14:30. Print, datetime.now, hashtag output, current datetime. Hashtag time delta. TD equals time delta, days equals 1, hours equals 2. Print, TD, hashtag output, 1 day, 2 hours. Hashtag formatting and parsing. Print, DT strftime, %y-m-%d%h%m%s, hashtag output, March 16, 2024, 14:30. Print, datetime.strptime, 2024-03-1614:30:00, %y-m-%d%h%m%s, hashtag output, March 16, 2024, 14:30. Note, the datetime module provides a comprehensive way to work with dates and times in Python. Python's datetime module. The datetime module is the primary tool for working with dates and times in Python. It provides classes for date, time, datetime, time delta, and tsinfo. Key classes and their uses. Date represents a date, year, month, day. Create a date object, date_obj equals date, 2024, 8/22. Access components, year equals date_obj.year, month equals date_obj.month, day equals date_obj.day. Perform arithmetic, future_date equals date_obj plus time delta, days equals 10. Time represents a time, hour, minute, second, microsecond. Create a time object, time_obj equals time, 15, 35, 20. Access components, hour equals time_obj.hour, minute equals time_obj.minute, second equals time_obj.second, microsecond equals time_obj.microsecond. DateTime combines both date and time information. Create a DateTime object. DateTime_object equals DateTime 2024 8 22 15 35 20. Access components. Year equals DateTime_object.year. Month equals DateTime_object.month. Day equals DateTime_object.day. Hour equals DateTime_object.hour. Minute equals DateTime_object.minute. Second equals DateTime_object.second. Microsecond equals DateTime_object.microsecond. Perform arithmetic. Future_datetime equals datetime_object plus time delta. Days equals 10. Hours equals 5. Time delta represents a difference between two datetime objects. Create a time delta object. Time delta underscore object equals time delta. Days equals 10. Hours equals 5. Perform calculations. Future_datetime equals datetime_object plus time delta_object. Tsinfo represents a time zone. Use predefined time zone objects or create custom ones. Apply time zone information to datetime objects. Formatting dates and times. Use the strftime method to format datetime objects according to specified patterns. Example, formatted_date equals datetime_object.strftime, %y-m-%d%h%m%s. Time zones. Python supports time zone awareness through the Tsinfo class. Use the pytz library for a comprehensive collection of time zones. Example, from pytz import time zone, tz equals time zone, Asia/Kolkata. Additional tips. Consider using the date_util library for more advanced date and time manipulation features. Be mindful of daylight saving time, DST, when working with time zones. Use appropriate data types for dates and times to ensure accuracy and avoid potential issues. Python Math. Python's built-in math functions. Python provides a rich set of built-in math functions for various mathematical operations. These functions can be accessed directly without importing any additional modules. Common math functions. Arithmetic operations. Plus, addition. Dash, subtraction. Asterisk, multiplication. Slash, division, floating point result. Slash, floor division, integer result. Percent, modulus, remainder. Exponentiation. Trigonometric functions. Math.sin, x sine of x, in radians. Math.cos, x cosine of x, in radians. Math.tan, x tangent of x, in radians. Math.assin, x inverse sine of x, in radians. Math.acos, x inverse cosine of x, in radians. Math.addan, x inverse tangent of x, in radians. Logarithmic functions. Math.log, x natural logarithm of x. Math.log10, x base 10 logarithm of x. Exponential functions. Math.exp, x exponential of x, e⁻x. Other functions. Math.sqrt, x square root of x. Math.ceil, x round x up to the nearest integer. Math.floor, x round x down to the nearest integer. Math.factorial, x factorial of x. Math.pi, mathematical constant pi. Math.e, mathematical constant e. Example usage. Import math. Hashtag arithmetic operations. Result equals 2 plus 3 asterisk 4. Print, result, hashtag output, 14. Hashtag trigonometric functions. Angle equals math.pi/4. Sine equals math.sin, angle. Print, sine, hashtag output, 0.7071067811865476. Hashtag logarithmic functions. Logarithm equals math.log, 100. Print, logarithm, hashtag output, 4.6051701859888092. Hashtag exponential functions. Exponential equals math.exp, 2. Print, exponential, hashtag output, 7.38905609893065. Hashtag other functions. Square underscore root equals math.sqrt, 25. Print, square underscore root, hashtag output, 5. Additional tips. For more advanced mathematical operations, consider using specialized libraries like NumPy or SciPy. Python's built-in math functions are generally sufficient for most common mathematical tasks. Ensure that your input values are within the valid range for each function to avoid errors. By understanding these concepts and utilizing Python's built-in math functions effectively, you can perform a wide range of mathematical calculations in your Python applications. Python's math module provides access to mathematical functions and constants. Here are some key functions and constants. 1. Trigonometric functions. Sin, x, sine of x. Cos, x, cosine of x. Tan, x, tangent of x. Asine, x, arcsine of x. Acos, x, arccosine of x. Adin, x, arctangent of x. 2. Hyperbolic functions. Sin, x, hyperbolic sine of x. Cosh, x, hyperbolic cosine of x. Tan, x, hyperbolic tangent of x. 3. Exponential and logarithmic functions. Exp, x, exponential function, e⁻x. Log, x, natural logarithm of x. Log 10, x, base 10 logarithm of x. 4. Power and root functions. Pow, x, y, x raised to the power of y. Sqrt, x, square root of x. 5. Rounding functions. Ceil, x, ceiling function, rounds up to nearest integer. Floor, x, floor function, rounds down to nearest integer. 6. Constants. Pi, mathematical constant pi, 3.14159. E, base of the natural logarithm, 2.71828. Example usage. Import math. Hashtag trigonometric functions. Print, math.sin, math.pi/2, hashtag output, 1.0. Print, math.cos, 0, hashtag output, 1.0. Hashtag hyperbolic functions. Print, math.sin, 1, hashtag output, 1.17520119364388014. Print, math.cosh, 1, hashtag output, 1.543080634815247. Hashtag exponential and logarithmic functions. Print, math.exp, 1, hashtag output, 2.718281828459045. Print, math.log, math.e, hashtag output, 1.0. Hashtag power and root functions. Print, math.pow, 2, 3, hashtag output, 8.0. Print, math.sqrt, 16, hashtag output, 4.0. Hashtag rounding functions. Print, math.ceil, 3.14, hashtag output, 4. Print, math.floor, 3.14, hashtag output, 3. Hashtag constants. Print, math.py, hashtag output, 3.141592655359. Print, math.e, hashtag output, 2.71828182846. Note, the math module provides a comprehensive set of mathematical functions and constants, making it a valuable resource for mathematical computations in Python. Python JSON. Python's JSON module provides methods for manipulating JSON data. Here are some key functions. 1. Encoding. JSON.dumps, obj, converts a Python object to a JSON string. JSON.dump, obj, fp, writes a Python object to a file in JSON format. 2. Decoding. JSON.loads, parses a JSON string into a Python object. JSON.load, fp, reads a JSON file and returns a Python object. 3. JSON data types. JSON objects are represented as Python dictionaries. JSON arrays are represented as Python lists. JSON strings, numbers, and booleans are represented as Python strings, numbers, and booleans. JSON null is represented as Python none. Example usage. Import JSON. Hashtag encoding. Data equals name, John, age, 30. JSON_string equals JSON.dumps, data. Print, JSON_string, hashtag output, name, John, age, 30. Hashtag decoding. JSON_string equals name, John, age, 30. Data equals JSON.loads, JSON_string. Print, data, hashtag output, name, John, age, 30. Hashtag writing to a file. Data equals name, John, age, 30. With open, data.json, w, as f. JSON.dump, data, f. Hashtag reading from a file. With open, data.json, r, as f. Data equals JSON.load, f. Print, data, hashtag output, name, John, age, 30. Note, the JSON module provides a simple way to work with JSON data in Python, making it easy to convert between Python objects and JSON strings or files. Python regex. Python's re module provides support for regular expressions. Here are some key functions and concepts. 1. Pattern matching. Research, pattern, string, searches for the first occurrence of the pattern in the string. Rematch, pattern, string, searches for the pattern at the beginning of the string. Refindall, pattern, string, finds all occurrences of the pattern in the string. 2. Pattern syntax. Matches any character. Caret, matches the start of the string. $, matches the end of the string. Matches either the expression before or after the end, groups expressions and captures matches. Matches any character within the brackets. Asterisk, plus, matches 0 or more, 1 or more, or 0 or 1 occurrences. 3. Modifiers. Re-ignore case, makes the pattern case insensitive. Re-multiline, makes the caret and $ anchors match the start and end of each line. 4. Groups and captures. Group, returns the entire match. Group, 1, returns the first captured group. Groups, returns all captured groups. Example usage. Import re. Hashtag pattern matching. String equals hello, world. Match equals research, world, string. Print, match.group, hashtag output, world. Hashtag pattern syntax. String equals hello, world. Match equals research, caret hello, string. Print, match.group, hashtag output, hello. Hashtag modifiers. String equals hello, world. Match equals research, world, string, ignore case. Print, match.group, hashtag output, world. Hashtag groups and captures. String equals hello, world. Match equals research, hello, world, string. Print, match.group, 1, hashtag output, hello. Print, match.group, 2, hashtag output, world. Note, the re module provides a powerful way to work with regular expressions in Python, making it easy to search, validate, and extract data from strings. Regular expressions in Python. Regular expressions, regex, are powerful tools for pattern matching and text manipulation. Python provides the re module for working with regular expressions. Key functions and usage. Recompile. Pattern compiles a regular expression pattern into a regular expression object. Example, pattern equals recompile, r\d+. Research, pattern, string searches for the first occurrence of the pattern in the string. Example, match equals research, pattern, the answer is 42. Rematch, pattern, string matches the pattern only at the beginning of the string. Example, match equals rematch, pattern, the answer is 42. Refindal, pattern, string finds all occurrences of the pattern in the string. Example, matches equals refindal, pattern, the answer is 42, and the other is 10. Resub, pattern, replacement, string replaces all occurrences of the pattern with the replacement string. Example, new underscore string equals resub, pattern, x, the answer is 42. Resplit, pattern, string splits the string at occurrences of the pattern. Example, parts equals resplit, pattern, the answer is 42, and the other is 10. Regular expression syntax. Metacharacters, special characters that have specific meanings in regular expressions. Matches any character except a new line. Caret, matches the beginning of the string. Dollar, matches the end of the string. Asterisk, matches 0 or more occurrences of the preceding character. Plus, matches 1 or more occurrences of the preceding character. Matches 0 or 1 occurrence of the preceding character. Or operator. Character set. Grouping. Escape sequences. \d, matches a digit. \w, matches a word character, alphanumeric or underscore. \s, matches a wit space character. \d, matches a non-digit. \w, matches a non-word character. \s, matches a non-white space character. Example. Python. Import re. Pattern equals r\d plus hashtag matches 1 or more digits. Text equals the answer is 42, and the other is 10. Hashtag find all matches. Matches equals refindal, pattern, text. Print, matches, hashtag output, 42, 10. Hashtag replace matches with x. New underscore text equals resub, pattern, x, text. Print, new underscore text, hashtag output, the answer is X, and the other is X. Additional tips. Use raw strings, R pattern, to avoid escaping backslashes. Consider using online regex testers to experiment and visualize patterns. Be mindful of performance implications when using complex regular expressions.